Hey, ATL. My name is Surya, and for this hackathon, we're making a diagnosis AI. So it's called DiagnAI. So basically, it is to help elders, younger people, people who don't have time to like go to a therapist and like understand what their problem is. We want it to be user friendly and just quick. We don't want like if people are depressed, we don't want them to like come in to a therapy session, fill out a bunch of forms, or like sit in like an online website and type a bunch of stuff. We want them to be interactive. We want to talk to them and get back answers. So we built like a speech to AI, speech to speech AI, where you can communicate with the AI to get like tell it about your lifestyle, see what's going on, and it will direct you to a specialist if you need help or like help diagnose you. So that's the basic gist of it, and I'll be panning it out to one of my teammates, and he will be explaining how it works a little more.
So basically, the main proposition is there are people who cannot. There are people like who cannot, who don't know what's what's cooking under. Wait, pause it.
One.
Hi, I'm Varun. So our proposition is that there are some diseases that develop and people don't even know about that. And the earlier we detect something, the better. The more chances for curing. So that's our philosophy. How is it working under the hood? Is this. So the user is gonna say something in natural language. We're gonna extract what emotion did the user have while saying that, and what text was in his speech. That's gonna go into a wrapper prompt, which is gonna have something like some instructions for the LLM underneath to how to generate the API, how to structure the output, and one of the it's gonna duplicate it. It's gonna be duplicated, and it's gonna pass through an embedded model. And without getting into like too deep into the pipeline, the basic idea is we're gonna have a vector database, which is gonna have medically accurate data corpus, all the medical literature and how to documents which are really important in like medical practices, actual past therapy sessions, all that kind of stuff, which is going to pass through the LangChain loading, preprocessing, and chunking pipeline, which is going to be converted into vectors and going to be stored into a vector database. We are using ChromaDB here, and we're going to have, let's say user says something, right? We're going to shortlist just a couple of documents from the entire huge database to what's relevant in this context of what user said, and we're going to pass it into another wrapper prompt, which is going to wrap every single thing that we talked about so far. And now the Claude API, the Claude model or any LLM that we might use here will know everything, the context, the actual medically accurate database, and what the user is saying. So it's going to understand everything, and it's going to generate a really accurate data, a really accurate output, which will be spoken out as a live speech.
Oh, hi, my name is Sheikh Mohammed Sufyan. So we also worked on the front end of the web app. So basically we used Streamlit for the front end and we used the Flask for the back end. For the web application, it has a basic login and a sign up page, which saves the user's data, which the application can use it for the future purposes. And that's it.
Dockerize.
Yeah, we are gonna containerize all the data, and by using a Docker, and we're gonna host it on the Google GCP.
Thank you. Peace out.